In optical transmission, we frequently use polarized light. If you want to find out what exactly polarized light is and what makes it so special, just stick around and we'll check it out. For optical data transmission, polarization is frequently used. Coherent transmission uses the polarization state to transmit different streams of data. Passive optical isolators, they are protecting lasers from light coming back. They are also using polarization. And silicon photonics chips, by the way, they are often using grating couplers, and those are very, very sensitive to polarization. But what do I mean when I talk about polarization? Basically, light oscillates in two planes, the P plane and the S plane. P stands for parallel and S stands for perpendicular. Huh? Okay, S is a German word, it's senkrecht and it means perpendicular. And as parallel is the same in German, it's P here. And in the P plane we have the green light, and in the S plane we have the blue light. So, having a look at this in 3 dimensions, here you can see the 2 planes S and P, and the black arrow indicates the direction of propagation of the light. And as you can see, here we have a polarization filter for S. This means the blue component is passing while the green one is blocked away. So how does this polarization filter work? You can imagine the polarization filter like a slot or like a grating. And if I now put it here on this sketch, you can see the blue component is passing, but the green one is blocked away. If I now turn this slot or this filter by 90 degrees, you can see the P component is passing and the S component is blocked. We've prepared a little experiment here. Here we have a light source and the polarization filter in front of the light source. So this means we have a linear polarized light. And if I now take a second filter, I put it in front of the light source, you hardly see any change. But if I now turn it by 90 degrees, you can see that the light is blocked away. Now, what is the difference from this light source to natural light? Natural light normally is from thermal beams or from thermal sources, and this means there's no certain polarization state. It's more or less chaotic. We have all the directions of polarization in this light source. And what does this mean if I want to put a filter in front of this? Let's take as an example the red plane here. And I've prepared it. And if we now focus on this red plane, you can see it's a vector. This means it can be divided into 2 components. We can project it to the P plane down here, and we can project it to the S plane here. So this means if I now take the filter and put it here to the projection, you can see this component of the red arrow is passing the filter and the rest is blocked away. If I now take the P component, rotating the filter by 90 degrees, it shows that the P projection is passing and the S projection is blocked. By the way, this means if this plane is perfectly 45 degrees, we have half of the light. There's a lot of more information on this topic of polarization. So if you are interested to learn more, please leave a comment and tell us what we should focus on for one of the next Brain Snack videos. And until then, see you. Bye-bye.